Video, we are going to discuss how to write a Verilog code for half adder and its simulation using model sim, then the RTL schematic. So first we'll select the new project wizard. In new project wizard, we are going to type our project name. So the project name is, I'll just give it as HA, and next I'll give it as the next, an empty project. And also we don't have any file to be added now, so we'll go to next. So here we will select the max 10 device. So whatever the default thing that we are going to make use of it. So we can use this particular device 10MA08DA F48CBG CAG. Then we can go to next. So in the next here we can specify what is our going to be our design entry. We are going to do the design entry using the XST. So and also we have for simulation. For simulation we can select a model sim Altera, and by default it comes to Verilog HDL. So we can select with the Verilog HDL. Then we can select next. Then after this the summary can be read. So once the summary is read, we can go for finish. So in the finish, once finished, you will get the text editors open here. So now we are going to create a new file. So in the new file, we are going to select the Verilog HTML file. Then the editor is opened here. Here we are going to type. It is a Verilog code for half adder. So this module is named as HA, and the output is going to be sum and carry. Then similarly we are going to have our inputs. Input are going to be the A and B. Input are A and B. Then we terminate it with a semicolon, and here we use a gate level modeling. So I just specify using gate level modeling. So using gate level modeling, we know the half adder um, circuit diagram. So it consists of an XOR gate and an AND gate. So you name it as X1 primitive, and the outputs are going to be the sum is the output for XOR, and A and B are the inputs. Similarly, we have a AND primitive, then AND primitive, we just name it as EA1, and here the output of AND is going to give the carry, then it's going to take the out inputs A and B. Then we can end module without a space. So that gives the end module. Then we can save this in our respective location. So here I create a new folder for a OR gate, sorry, for a half adder. So half adder folder is created, and inside this the file is going to be saved with an extension .v. So that's a Verilog. Then we can select that add file to the current project. Then we can select save. So the file is getting saved over here. Then we, in the analysis part, we expand it and we run the analysis and elaboration. This will give us that if there is any error. So if there is no error, we will be prompted with 0 errors. Otherwise, the prompting for the particular error will be shown here. So it is now it's going on. We have 4% here, and immediately that will get synthesized. So 95% says 0 errors and 1 warning. So warning we neglect at this point. So later we can see to that. Once again we will run our RTL simulation. model sim is opened again here. Then next what we do, we go to work and we'll right click and simulate it. So we right click and simulate. It is there in the objects. So we select all the contents and we'll send it to add wave new. So we'll be able to see that the signals are added to the waves, and now we'll arrange our signals at the bottom, outputs at the bottom. Then now we will set the clock for this. So clock, it is with a 100 period. Okay, we will say okay. Then similarly the B, we will set again a clock. Now with the duty cycle, I'll change it to 25, so that we'll try to get different possible conditions. So as now I'm going to run this. As I run this, I'll be able to see it is run for 500 picosecond. And here when I place the marker, I'll be able to see that when A and B are 1 1, sum is 0, carry is 1. When it is 1 0, sum is 1, carry is 0. When all are 0, this is going to be uh, 0. And similarly 1 0 also, it's going to be 1 0. And similarly the patterns can be checked. 1 0 1 0 will be there. Even if you want to change the pattern, we can change the pattern here with the different time period. Now let us say the 50 for B. Then I'll just run it again. Now we'll have all the combinations 1 0. Then 0 1 is also available, 0 0, and 1 1 is also available. So 1 1 0 1 is the output. So now it's working as a half adder. Then what do? We close this window and we'll move back to our Quarters. In a Quarters, what we do, we go for tools and we select for the simulate that synthesis. So in the synthesis, we are going to check the netlist viewers. In the netlist viewers, we are going to check the RTL viewer. So here we will be able to see that a half wave module is developed with an OR gate and an XOR gate, and the XOR gate and an AND gate, and the output of the XOR gate is given to sum, and the output of the AND gate is given to carry. So the system very well able to interpret our code and to develop a hardware called half adder. Okay. Now let us discuss how to implement half adder using data flow modeling and what are the constructs we are supposed to use. So data flow modeling uses continuous assignment statement, and either data flow modeling or gate flow modeling, the module and its interfaces remain same. So we have two outputs and we have two inputs. Some carry the output and A and B are the input. So in data flow modeling, we use a statement called assign. So in the assign statement, we assign for some net, we assign the expression A XOR B, and similarly for carry, we assign the expression A or operation A ampersand B, A and B. So now let us save this, and once again, since it is modified, we are going to restart it again, this analysis and elaboration part. So once this is done, then we can go for a RTL simulation. In RTL simulation, we'll be able to see that it's performing as a half adder or not. Then we'll start with the RTL simulation. So as usual, we are going to perform RTL simulation in model sim. So as we perform in the model sim, we check in the library, we have the work there. Here we have a simulate option, and as soon as we get the objects for simulation, then we add this to the new wave, and in the wave window we are going to rearrange our outputs as per our convenience. Then I pass a clock to the signal A, which is having 100 nanosecond time period and also 50 duty cycle. Then here we have another clock. I'm setting it here. Now this is with the period 25, so that we'll try to get as many possible as we can. And so click OK for this. Now when I run this, I'd be able to see different possible combinations. So I'm zooming in for my convenience. So here we get for combination 1 1, that is going to be 0 1. Then we get for 1 0, sum is 1, carry is 0. Then 1 1, sum is 0, carry is 1. And 1 0, then 0 1 also. We'll be able to get 0 0 also we're getting. So all the combinations we're able to get it from here. So that means it is working as an half adder. So let us close the model sim and we'll get back to the quarters. In quarters, we are going to now check, we are on the RTL schematic. So in the RTL viewer, we'll be able to see how it is getting interpreted. So very well it is interpreted here. So the primitive XR is the selected here for implementing some operation, and a primitive AND is selected for implementing carry option. Although we defined in a data flow modeling, both having the same kind of informations here. Even in a gate level also we'll be able to see similar kind of work was implemented. Okay, thank you.